Hello friends, in this session we are going to talk about centroid and area of a triangle in the coordinate geometry. So friends, let's now see how do we find the coordinates of the centroid of a triangle whose vertices coordinates are provided to us. Now let's take a triangle ABC whose vertices are the coordinates are provided to us. For A it is x1, y1, point B is x2, y2 and vertex C is x3, y3. Then the centroid of this triangle is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So these are the coordinates of the centroid of the triangle. Now here we can see that the midpoint of the point of the side AB is x1 plus x2 by 2, y1 plus y2 by 2. Let's take this point to be D. Now the centroid divides the CD, the median CD in the ratio 2:1. So we can find out using the section formula, we can find out the coordinates of the centroid as 2 into x1 plus x2 by 2 plus x3 whole divided by 3, and the y coordinate would be 2 into y1 plus y2 by 2 plus y3 whole divided by 3, which comes out to be x1 plus x2 plus x3 by 3, that being the abscissa of the centroid, and y1 plus y2 plus y3 by 3 being the ordinate of the centroid. So this is where we use the section formula to find out the centroid, and this centroid formula would be used in the triangles. So friends, now let's see how do we find out the area of a triangle whose vertices are provided to us. Now this area of this triangle with the vertices x1 y1, x2 y2 and x3 y3 is given by this formula, which we are going to just see how do we arrive at this, and then we'll see what the formula is. Now if we take this triangle ABC drawn here and we draw the perpendiculars AD, CE and BF to the x-axis, perpendicular to the x-axis. Now we can clearly see that the area of this triangle ABC is equal to the area of trapezium ACED plus the area of the trapezium BCEF minus the area of this trapezium, which is ABDF, this one. So we are saying we take this area plus this area minus this area in red. So we get the area of this triangle. Now what is the area of the trapezium? We know it is half into the sum of parallel sides into the distance between the parallel sides. So now for the trapezium ACED, we have half into the parallel sides being AD plus CE into the distance between the parallel lines, which is DE. The area of the trapezium BCEF is half into the parallel side CE plus BF into EF, which is the distance between the parallel lines, minus the area of the trapezium ABDF, which is half into AD plus BF into the distance between the parallel sides, which is DF. Now we know AD is nothing but y1, CE is nothing but y3. So we said half we take out common from the 3 and we say y1 plus y3 into DE, which is x3 minus x1. So this becomes the area of the first trapezium, plus we have CE plus BF, CE being y3 and BF being y2. So we say this becomes y3 plus y2 into EF, which is nothing but x2 minus x3. So this is the area of the second trapezium minus the area of the third trapezium, which is AB DF. So here we have AD plus BF, AD being Y1 plus BF being Y2. So minus Y1 plus Y2 into, we have DF, which is X2 minus X1. So this is what we get. Now we can take the terms of X1 common, and we say take out X1 into Y2 minus Y3 plus X2 into Y3 minus Y1 plus X3 into Y1 minus Y2. This is just simplified to make it like this. Since the area is a numerical value of this expression, we can write it as half into mod of, because we are saying if this numerical value somehow comes out to be, numerical value has to be taken, we don't have to take the sign, so we take mod of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the area of the triangle, knowing the coordinates of its vertices. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.